Have you asked yourself how you access resources within a computer system or in an information system? Well, today I want us to have a conversation about access control models because that is how you are given access to these resources. And in in the in their pure sense, access control models are mechanisms that define how users or processes are granted permissions to access resources like files, systems, and services. It is like we are talking about different gates that you can use to access computing resources. And that is what I want us to discuss. And there are about six common models of access control. So, number one, we have the discretionary access control. In fact, that is what we will discuss in this short video. We have number two, we have mandatory access control. Number three, we have role-based access control. And number four, we have attribute-based access control. Number five, we have rule-based access control. Number six, and finally, we have context-based access control. So let us have a discussion of the first access control model, which is a discretionary access control. Now, DAC or discretionary access control allows resource owners to determine who has access to to their resources and what type of access. For instance, in Linux-based system or basically Unix-based systems that include Macintosh, Macintosh machines, that includes PCs that are running on Ubuntu or any Debian-based operating system or Red Hat based system. So these systems uh, essentially will have a root user that has a lot of power. That the root user is similar to an administrator in Windows PCs. So the root user can grant access to uh, to processes, to files. In fact, everything in Linux is basically a file, right? So those files and executables are files, right? As we shall see. In fact, I'll do a demo on that. So files do not have default access to execute. If you have an executable, you have to explicitly give it the rights to execute, right? So some of the other permissions are read, write, um, so and execute. So there's a time I was deploying an application that at one point when it uploaded a document, it was supposed to create a folder if that folder uh, didn't exist, the uploads folder. Then I realized this thing is working on my PC, but when I transfer it to the Ubuntu server, it is not working. Incidentally, and I was a junior at that point, incidentally, it was a permissions issue. So when I escalated to my CTO, I was told, just go and read about permissions in Linux. When I gave, I think it was the Nginx user uh, uh, ownership, number one, ownership to that directory, and then I also gave access, read, write access to the Nginx user. I was able the system, the scripts in that folder were that particular script was able to create a folder when necessary. So that is one example. Another example that I will show is actually when you're using an executable file. For those of us who use frameworks for software development, for me, I like one of my favorite framework is the Yi2 framework. Uh, it's a PHP framework for web development. And when you download it, it has an executable that you use to run commands, command line instructions as you do various things to initialize, to run your other commands. If you have command-based interfaces within your application, um, and that particular executable, you have to give it explicitly. You have to give it executor permissions to execute. If you fail to do that, you cannot even uh, be able to see the version of year two that you're running, and that is what I want to show. So, what are the common characteristics of discretionary access control? Number one, it is based on user identity and group membership, and this you will see in Ubuntu. When you're changing ownership, the ownership is based on the ownership bit is based on the user and the group, right? So if let's say you're giving Nginx particular permission on a folder, particular ownership on a folder, when you change the ownership, you'll begin by the user Nginx who belongs to the group Nginx, right? And ideally, the permissions you have given, when you give ownership to to a certain directory to Nginx, and then you give certain permissions to that user Nginx. So everyone else sort of who belongs to that group inherits those permissions. So it is based on user identity and group membership. The other thing, it is common in most operating systems, as we shall see, Windows and Unix-based operating systems, and it uses access control lists. So, ladies and gentlemen, I hope you have at least gotten an idea of when we say uh, we need to implement access controls in particular systems, what we mean by the access control models. So we essentially said, with regards to systems, these are sort of types of gates and their own properties and how they are managed, right? The same way you would have a home that has an automated uh, gate that uses something to do with infrared, one that is manually opened, um, one that is has two has opens like a two door in two halves, one that slides across. So that is the same aspect with regards to cybersecurity and information security as we had defined them earlier. So these are mechanisms that essentially define how users, processes, are granted permissions to access resources within an ecosystem of computer systems or information systems. So, with that, let's look forward to the rest of the models, discussing them in detail and showing, just showcasing where they are applied. So, let me try to do a demo. Let me actually uh, type try to show you how this discretionary access control is done in Windows. Um, so the first thing I'll do, I'll go to IIS. So here I am. I'm going to IIS, which is the Windows web server, and I'm expanding the sites. So I have one site here. This is called contracts. So on the left-hand side, where you see actions, there's explore and then there's edit permissions. So I'm the administrator of this machine. So it's a local machine. So let's see, and I say edit permissions, so on the web properties, there's security, right? So you can see, as I said, it is the discretionary access control. It is based on users and group memberships. So you can see here, I'm told groups or usernames. So that is one characteristic, characteristic of it. So here, if I decided not to say everyone here has the following permissions for full control, modify, read, and execute, list folders. It means if it were a domain context, then anyone in that in anyone in that domain would have access to do whatever they want because you see they have full control. So you can decide to say, let me see. You can decide to say for everyone, I want to deny. You can see. So if I say apply, you see you have denied the everyone group access to web. You see? So that is interesting. That is how you'd now deny everyone access to that particular folder that has those files. Again, if I click on it and then try to see what permissions are with everyone, you can see they are denied, right? But the IIS user here has access to this. I can decide, even for the IIS, I'm going to deny. But essentially, this is the user who runs the web server. So if I denied this, the web application will not be rendered. So that is the essence of the discretionary access control. It is centered on users and group membership. Again, the owner or the administrator of the system can give access to any group or entity they feel they need to give permissions to. So if I was in a domain, you can see here the user. This is not a group. What I have highlighted, this is the admin. This is the administrator. The administrator also has permissions here, right? You can see. So the same point still stands, that discretionary access control allows the resource owner, in this case the administrator, to determine who accesses their resources and what type of access they are granted. As always, we are extremely grateful for those of you who gives us a minute, an ear, an eye, who watch our content. If there's anything you'd want us to improve, please do not hesitate to let us know. Thank you.